Many people look at this rapid change and feel a sense of anxiety or confusion. They see headlines about AI, the cloud, and quantum computing and think, that's not for me. That's for geniuses in secret labs. But today, I want to pull back the curtain. I want to be your guide on a journey through 7 of the most critical, exciting, and in-demand career paths that will not only define the next decade, but will empower you to become an architect of that future. This isn't just a list of jobs. This is a story about a new generation of pioneers, problem solvers, and dreamers. And by the end of our journey, you might just see a place for yourself in that story. 1. The Digital Alchemist, AI Machine Learning Specialist. For centuries, humanity's been fascinated by the idea of creating intelligence. From the golem of folklore to the robots of science fiction, we've dreamed of breathing life into the inanimate. Today, that dream is becoming a reality, not through magic, but through mathematics. The modern-day alchemists, who are turning data into intelligence, are the AI and machine learning specialists. But what does that really mean? Forget the image of a sentient robot overlord for a moment. Think of it like this. You're teaching a toddler to recognize a cat. You don't write a long list of rules like if it has pointy ears and whiskers and a long tail and says meow, it's a cat. That's old school programming. Instead, you show the toddler thousands of pictures of cats, big cats, small cats, fluffy cats, sleeping cats. Eventually, their brain forms a pattern, an intuition. They just know a cat when they see one. That's what an AI specialist does. They take vast amounts of data, the pictures, and feed them into a framework, an algorithm they've designed. The machine learns the patterns, the nuances, the intuition, all on its own. The core skills here are the tools of this digital alchemy. Python is the universal language, the flexible and powerful spellbook they use to write their instructions. TensorFlow and PyTorch are like the sophisticated laboratories, the pre-built environments where they can conduct these complex learning experiments without having to build everything from scratch. Then you have the specialized fields. Natural language processing, NLP, is the art of teaching machines to understand and use human language. Every time you ask Siri for the weather, or your email sorts spam from your inbox, you're witnessing NLP at work. It's about understanding context, sentiment, and intent, not just words. Computer vision is teaching machines to see and interpret the world. This is the magic behind self-driving cars identifying pedestrians, or a security camera flagging suspicious activity, or even an app on your phone that can identify a plant from a single photo. But as this power grows, so does the responsibility. The article mentions AI ethics, and this is arguably becoming the most important skill of all. An algorithm is only as good as the data it's trained on. If you train a higher-end AI on data from a company that has historically favored men, the AI will learn that bias and perpetuate it. The AI specialist of the future is also a philosopher, an ethicist who must ask, is my creation fair? Is it transparent? How do we build systems that uplift humanity, not entrench its flaws? This is where software engineering discipline, a deep understanding of statistics, and a strong moral compass come together to create technology that is not just smart, but wise. 2. The Digital Guardians, Cybersecurity Analysts. Every incredible innovation we just discussed at AI, the data, the interconnected systems, creates something of immense value. And wherever there is value, there are those who will try to steal, disrupt, or destroy it. As our world moves online, the castles we build are digital, the vaults are made of data, and the walls are code. Standing guard on those walls are the cybersecurity analysts. These are the silent heroes of the digital age. They aren't just reacting to problems. They are the proactive defenders, the digital detectives, and the strategic masterminds of defense. Think of a cybersecurity analyst not as a simple security guard at a door, but as the head of an entire intelligence agency for a company. They are constantly studying the enemy, the hackers, the malware, the state-sponsored actors to understand their tactics and anticipate their next move. Their toolkit is fascinating. The article mentions intrusion detection, which is like having a network of invisible motion sensors and silent alarms all over your digital infrastructure. The moment an unauthorized entity even touches a digital doorknob, the analyst knows. They use a philosophy called zero trust architecture. The old way was a castle with a moat. Once you're inside, you can go anywhere. Zero trust assumes the enemy is already inside. It's like a high security building where you need to swipe your key card not just at the front door, but for every single room, every single filing cabinet. It trusts no one and verifies everything, dramatically reducing the potential damage of a breach. Their weapons of choice are often scripts written in Python or Bash. These aren't just for defense, they're for automation. Imagine having to manually check thousands of logs every single hour. It's impossible. An analyst writes a script in automated watchdog that sifts through that mountain of information 24/7 and only barks when it finds something truly suspicious. This frees them up to focus on the real complex threats. And in this field, trust is everything. That's why certifications like CEH, Certified Ethical Hacker, or CompTIA Security Plus are so vital. A CET is essentially a license to think like a hacker. You learn to break into systems so you can learn how to defend them. It's the ultimate know your enemy qualification. As our lives become filled with IoT devices, smart fridges, smart watches, smart everything, and remote work becomes the norm, the attack surface has exploded. Every new device, every home Wi-Fi network is a potential doorway for an attacker. The modern cybersecurity analyst is the one drawing the new defensive map for this vast, interconnected, and vulnerable world. 3. The architects of the invisible, cloud computing engineers. So we have the AI creating intelligence and the cybersecurity, analysts protecting it. But where does all this digital stuff live? It doesn't sit on a single computer in an office anymore. It lives in the cloud. And the people who design, build, and maintain this incredible, invisible infrastructure are the cloud computing engineers. When you hear the cloud, don't picture the sky. Picture a global network of massive, hyper-secure, and unimaginably powerful data centers owned by companies like Amazon, Oz, Microsoft Azure, and Google, GCP. A cloud engineer is like a master architect and city planner for this digital world. A company no longer needs to buy its own expensive servers, real estate, and cooling systems. Instead, they can rent a plot of digital land in the cloud, and a cloud engineer builds their entire operation there. Their skills are all about building efficiently, securely, and at scale. Think of Docker. In the old days, if you build an application, it might work on your computer, but break on someone else's because of tiny differences. Docker is like inventing the shipping container. It puts your application and everything it needs into a neat standardized box that will run exactly the same way anywhere on a developer's laptop, a testing server, or in the massive OEA cloud. Kubernetes is the crane and logistics system for these containers. If your app suddenly gets 1 million users, Kubernetes automatically deploys hundreds or thousands of new containers to handle the load, and then scales them back down when traffic subsides. It's a traffic manager for the digital city. The term DevOps describes a cultural shift that cloud engineers champion. It breaks down the old walls between developers who build the software, dev, and the operations team who run it, ops. Using tools for CI/CD, continuous integration, continuous deployment, they create automated pipelines. Imagine a factory assembly line. A developer writes a piece of code, commits it, and an automated system instantly tests it, integrates it, and deploys it to the cloud. This allows companies to innovate at a breathtaking speed. The future for these architects is even more exciting. Serverless computing is the next step. You don't even have to manage the containers anymore. You just provide the code, and the cloud platform runs it for you, like magic. Hybrid cloud systems allow a company to use both its own private servers and the public cloud. getting the best of both worlds. And with multi-cloud expertise, an engineer isn't locked into just one provider. They are the masters who can build bridges between AWS and Azure, choosing the best tool for the job, optimizing costs, and ensuring their digital city is resilient, efficient, and ready for the future. 4. The storytellers of numbers, data scientists and analysts. Our world is now generating data at a pace that is simply staggering. Every click, every purchase, every GPS location, every social media post, it's a torrent of raw information. To most, this is just noise. But to the data scientists and analysts, it's a hidden story waiting to be told. These are the digital detectives and translators of our time. There's a crucial difference between the two roles, though they work hand in hand. A data analyst is often looking at the past. They are the historians of the data. They take existing datasets and answer the question, what happened? They might analyze sales figures from the last quarter to figure out which marketing campaign was most effective. Their primary tools are things like SQL structured query language, which is the universal language for asking questions of a database, and visualization tools like Tableau, which is like their paintbrush to turn boring spreadsheets into beautiful interactive charts that a CEO can understand in seconds. A data scientist, on the other hand, is often looking toward the future. They use the work of the analyst to answer the question, what will happen and what should we do about it? This is where the world of data science overlaps with AI and machine learning. They use languages like Python and R to build predictive models. For example, they might analyze customer behavior to predict which customers are likely to cancel their subscription, allowing the company to proactively offer them a discount. They work with big data frameworks like Hadoop and Spark, which are the heavy-duty industrial machinery needed to process datasets so massive they can't fit on a single computer. The most critical skill, and the one that separates a good analyst from a great one, is storytelling. A data scientist doesn't just deliver a report full of numbers. They weave a narrative. They'll stand in front of the board and say, our data shows that customers in the Southwest are buying our product, but they stop using it after 3 weeks. My model suggests this is because of the high humidity affecting the product's performance. Here's a story of a customer, Sarah from Phoenix, and her journey. If we reformulate the product for her climate, we can unlock a new market. They turn data into empathy, and empathy into action. As the article notes, data ethics is paramount here as well. With great insight comes great responsibility. How is user data being collected? Is it secure? Is it being used to manipulate people? A great data scientist has a deep respect for privacy and a commitment to using their powerful insights for good. 5. The choreographers of the physical world, robotics and automation experts. For decades, we've thought of robots as clunky, repetitive machines bolted to a factory floor, mindlessly welding car doors. That era is over. Today's robotics and automation experts are creating machines that are intelligent, adaptable, and collaborative. They are the bridge between the digital world of code and the physical world of motion. There are two major branches to this exciting field. The first is what we traditionally think of, physical robotics. These experts are designing the intelligent machines you see in advanced manufacturing, logistics warehouses, and even operating rooms. Their skills are a unique blend of mechanical engineering, electrical engineering, and computer science, a field known as mechatronics. They use powerful programming languages like C++ for high speed, real-time control, and Python for higher-level AI functions. The key framework here is Robot Operating System. It's not a traditional OS like Windows, but a flexible framework of tools and libraries that helps developers build complex robot behaviors without reinventing the wheel. Imagine giving a robot the ability to see a box, plan a path to it, and pick it up. Oros provides the building blocks for all of that. The second and rapidly booming branch is robotics process automation, RPA. This is where the robot is actually a piece of software. Think about all the repetitive, mind-numbing tasks that office workers do every day. Copying data from an email to a spreadsheet, processing invoices, generating standard reports. An RPA expert uses tools like UiPath to build software bots that can watch a user perform a task, learn it, and then do it themselves 24/7 with perfect accuracy. This doesn't necessarily replace human workers. It frees them from drudgery to focus on more creative, strategic, and high-value work. It's about automating the clicks, not the creativity. As these physical and digital robots become more integrated into our lives, from surgical assistants to delivery drones, the expertise in safety, protocols, and ethical considerations becomes not. How do you ensure a collaborative robot working alongside a human never causes harm? What are the ethical rules for an autonomous delivery drone? The robotics expert of the future is not just a programmer or an engineer. They are a choreographer of the intricate dance between human and machine. 6. The dream weavers of new realities, AR, VR, and spatial computing. For all of human history, we have been limited to interacting with the digital world through flat 2D screens. We poke at glass rectangles. But what if we could step inside the information? What if the digital world could overlay onto our physical world? This is the promise of augmented reality, AR, virtual reality, VR, and the broader field of spatial computing. The professionals in this space are not just building apps. They are building entire new realities. Virtual reality, VR, is about total immersion. You put on a headset, and you are transported to another place, a fantasy world, a historical site, or training simulation. Augmented reality, AR, is about overlaying digital information onto the real world. Think of the Pokemon Go craze or an IKEA app that lets you see how a couch would look in your living room before you buy it. Spatial computing is the umbrella term for all of this. It's about breaking technology out of the screen and allowing it to understand and interact with the 3D space around us. The workshops for these dreamweavers are powerful game engines like Unity and Unreal Engine. While they were born from the gaming industry, their use has exploded. Architects use them to let clients walk through a building before a single brick is laid. Medical schools use them to create hyper-realistic surgical simulators where students can practice complex procedures with zero risk. Their programming languages are typically C# for Unity and C++ for Unreal. But building a world is more than just code. It requires 3D modeling, the art of sculpting the digital objects, characters, and environments. It requires a deep understanding of UX, UI, user experience, user interface design that goes far beyond buttons on a screen. How does a user navigate a virtual space? How do you make the experience intuitive and not disorienting or nausea-inducing? This is a completely new design language. They must also be masters of optimization, ensuring that these incredibly complex worlds can render in real time, tracking motion flawlessly to maintain the illusion. As we hear more about the metaverse and digital twins, a virtual replica of a physical object or system, the work of these professionals becomes central to the next evolution of the internet. They are the ones figuring out how we will work, play, learn, and connect in these new immersive spaces. They are not just engineers. They are world builders, experienced designers, and pioneers of a new kind of human-computer interaction. 7. The pioneers at the edge of reality, quantum computing professionals. We've journeyed through careers that are shaping our world today and in the near future. But now we arrive at the very edge of what's possible. We arrive at a field so new, so mind-bending, that it operates on the fundamental laws of the universe itself. This is the realm of quantum computing. Every computer you have ever used, from your smartphone to the most powerful supercomputer, works on a simple principle. A bit of information is either a 0 or a 1. It's like a light switch. It's either off or on. This is classical computing. Quantum computing throws that rulebook out the window. A quantum bit or qubit can be a 0, a 1, or both at the same time. This bizarre state is called superposition. It's like a spinning coin until it lands. It's both heads and tails. This single difference, when scaled up, gives quantum computers the potential to solve certain types of problems that would take a classical computer billions of years to crack. Think about discovering a new life-saving drug. It involves simulating how millions of complex molecules might interact. A classical computer has to test them one by one. A quantum computer, by leveraging superposition and another quantum phenomenon called entanglement, can explore a vast number of possibilities simultaneously. It's the difference between trying every key on a keychain one by one and being able to try all of them at once. The professionals in this field are true pioneers. They require a skill set that is fundamentally different from the others we've discussed. A foundational knowledge of quantum mechanics and advanced linear algebra is not a bonus. It's a prerequisite. They work with specialized quantum SDKs, software development kits like IBM's Qiskit, which allow them to write algorithms that harness these quantum effects. Today, the roles are concentrated in research and development, both in software and hardware engineering. They are tackling problems in cryptography, building new encryption methods that are safe from future quantum attacks, materials science, and complex optimization problems for finance and logistics. This is not a field you stumble into. It is a deep, challenging, and profoundly rewarding path for those who want to build the machines that will solve problems we can currently only dream of solving. We've traveled from the intelligent algorithms of an eye to the mind-bending realities of quantum mechanics. And as we stand here at the end of this journey, it's easy to feel overwhelmed. But I want you to take a deep breath and see the single golden thread that ties all of these incredible fields together. They are all about solving human problems in new and creative ways. None of these careers are just about being good at computers. They are about curiosity, creativity, and a relentless desire to learn. The AI specialist is trying to cure disease. The cybersecurity analyst is trying to protect people's life savings. The cloud engineer is building the stage for the next great innovation. The data scientist is finding the truth hidden in the noise. The robotics expert is making human work safer and more meaningful. The AR/VR professional is creating new ways to learn and connect. And the quantum pioneer is pushing the very boundaries of human knowledge. So, the lesson I draw from this, and the advice I want to leave you with, is this. Don't start by asking, which technology should I learn? Start by asking yourself a more fundamental question. What kind of problem do I want to solve? Are you passionate about justice and fairness? Maybe AI ethics or data ethics is your calling. Do you love building and creating resilient systems? Cloud engineering could be for you. Are you a storyteller at heart who sees patterns where others see chaos? Data science is waiting. The technology is just a tool. Your passion, your empathy, and your drive to make a difference, that is the true engine of your future career. And that brings me to my question for you. After hearing about these 7 paths, which one sparks your imagination the most? Which field makes you lean in and say, tell me more? And if you had the skills from one of these professions, what is the first problem in the world you would try to solve? Leave your thoughts in the comments below. I genuinely love reading them and seeing where your passions lie. It's a conversation that helps us all learn and grow. Thank you so much for joining me on this journey today. I hope it left you feeling inspired and empowered, not intimidated. Please take care of yourselves and be well. And if this story sparks something in you, if you're curious about where the future is heading and how you can be a part of it, do me a favor and hit that subscribe button. We have many more journeys to take together. Until next time.